Welcome back. In this lecture, we will cover internal rate of return or IRR analysis. Let's look at what is meant by IRR. IRR is the discount rate or simply the rate of return at which NPV of the project is zero. So the discount rate which makes NPV of the project equal to zero is the internal rate of return. In other words, IRR is the just rate of return that you will obtain if you invest in a project. So it is the measurement of the profitability of the project. Let's look at the acceptance criteria of IRR. If IRR is greater than cost of capital or discount rate, the project will be accepted. And if IRR is less than the cost of capital or the discount rate, the project will be rejected. Now let's look at an example of IRR. In this example, your investment is $100 and after 1 year, you will receive $110. Now, you need to find out the internal rate of return of your investment. So you have to find out the discount rate which will make the NPV of your investment equal to zero. If you use 10% discount rate for your investment, you'll find that NPV of your project is zero. So in this case, IRR is equal to 10%. So in other words, in a simply 100 is your investment, $110 is your return, so your return is 10%. As it is a 1 year project, it is pretty simple to find out internal rate of return or simply rate of return of the investment. Now let's look at an solve problem of IRR. So here there are two projects, project S and project L. Discount rate of these projects are 10%. Let's look at project S. It has an initial investment of $1,000. So this $1,000 is negative. Then $500 cash flow in year 1, $400 in year 2, $300 in year 3, and $100 in year 4. If we put these values in NPV formula, that's minus 1,000 is your initial investment, then 500 divided by 1 plus IRR to the power 1, and then $400 which is the cash flow of year 3 divided by 1 plus IRR to the power 2, then 300 divided by 1 plus IRR to the power 3 plus 100 divided by 1 plus IRR to the power 4. So over here, you need to find out the IRR. So you need to find out the discount rate which will make the NPV of this project zero. If we use 14.489% discount rate, NPV of project S will be zero. So in this case, IRR of project S is 14.489%. Now the question is how we can calculate IRR. There is one method which is trial and error. So we have to try with different discount rate. Then in this way, we have to find a single discount rate which will make the NPV of the project zero. Realistically, this method is next to impossible. So we have to use either Excel or financial calculator to calculate the IRR. There is no other alternative. Now let's look at the IRR of project L. IRR of project L is 13.549%. If these projects are independent, you can accept both projects because both projects have IRR more than discount rate or cost of capital. Discount rate over here is 10%. So both projects generate IRR with more than 10%. So both projects are accepted if projects are independent. However, if the projects are mutually exclusive, we have to accept project S because IRR of project S is more than IRR of project L. Now let's look at the reinvestment rate assumption of IRR. IRR method assumes that project's cash flows will be reinvested at internal rate of return. That means the calculated internal rate of return. And because of this assumption, NPV method is better than IRR because it is more realistic to reinvest cash flows at opportunity cost of capital or simply the discount rate. So reinvestment assumption of IRR is unrealistic. Now let's look at the disagreement between NPV and IRR, and what should you do if there is a disagreement between NPV or IRR. If NPV and IRR give you different recommendation or different outcome, in this case you should always go with the NPV. So if there is a disagreement between NPV and IRR outcome, in that case you should accept the project which is recommended by NPV rule. Now let's look at some limitations of IRR. First of all, focusing on IRR alone can be misleading. Now let's compare these two projects. So there are we have two projects, project L and project B. Cash flows of project L is minus 10 million at time 0 and 11 million at time 1, and project B has a cash flow of positive 10 million at time 0 and negative 11 million at time 1. Both projects have cost of capital of 5%. Now if you look at the NPV of IRR of both projects, we can see that NPV of project L is 4,76,190 positive, whereas NPV of project B is negative. But if you look at the IRR, both projects have 10% IRR. So based on the NPV, we can see that project B should be rejected as it will decrease the shareholders' wealth. So we should definitely reject project B. But IRR says that both projects are accepted. So if we accept this project based on IRR, our decision will be misleading. So this is how it is often said that IRR provides misleading outcome. Here is another example. So we have two projects here, a small budget project and project large budget. So a small budget project requires $50 million investment and large budget project requires $120 million investment. A small budget will generate $80 million cash flow in year 1 and project large budget will generate $180 million cash flow in year 1. Now if you look at the NPV and IRR of both projects, you can see that based on internal rate of return or simply IRR, a small budget project should be accepted, as IRR of a small budget project is 10% more than the IRR of project large budget. Now if we look at the NPV, we can see that NPV of a small budget project is 14 million, whereas NPV of project large budget is 24 million. So large budget project will add 10 million more value to the shareholders or to the business. So based on NPV, we should definitely accept project large budget. So over here again we see that IRR often gives us misleading outcome. Here is another example. There are two projects, long-term project and short-term project. Now long-term project and short-term project both require $100 million initial investment. The long-term project will not generate any cash flow in year 1 and it will generate $144 million cash flow in year 2. On the other hand, short-term project will generate $121 million cash flow in year 1 and it will not generate any cash flow in year 2. Now, if you look at the IRR, long-term project has a IRR of 20%, whereas short-term project has a IRR of 21%. So based on IRR, short-term project is better than long-term project. Now, if we look at NPV of these projects, you can see that long-term project has an NPV of $19 million, whereas short-term project has only $10 million NPV. So based on NPV, long-term project is much better than short-term project, whereas based on IRR, short-term project is slightly better than long-term project. So again, we can see that IRR gives us misleading outcome. Now let's look at another limitation of IRR. In many cases, some projects might have multiple IRR. Let's look at this example over here. So cash flow of this project is as follows. Initial investment is 100 million, which is negative. Then it will generate 230 million cash flow in year 1. And in year 2, the project will require another $132 million investment. Now, if you calculate the IRR manually, you'll find there are two IRR. With 10% rate of return, 10% IRR, NPV of this project will be 0. In the meantime, with 20% IRR, NPV of this project will be also 0. However, if you calculate the IRR using Excel, there will be only one IRR, but if you calculate it manually, you'll find there are two IRR, 10% and 20%. So, over here, because of this two IRR, this result is confusing. Which one should we accept, 10% or 20%? So, this is one of the limitations of IRR. However, this problem can be solved by modified internal rate of return, though we are not covering modified internal rate of return in this course. Now let's look at another limitation of IRR. Sometimes the IRR of a project does not exist. Now let's look at the cash flow of a project. The project will generate $100 million cash flow at time 0. Then it will generate 300 million negative cash flow in year 1, and year 2 again it will generate 230 million cash flow. If you want to find out the IRR of this project, you will not find anything. So there is no discount rate at which NPV of this project is 0. So you will not be able to find out any internal rate of return of this project. So this is another limitation of internal rate of return. As projects like this, sometimes the IRR of the project does not exist. That's all about this lecture. In our next lecture, we'll cover alternative to discounted cash flow techniques.